Children, now we are going for the next episode, number 12. Let us go through the previous class. We discussed about some properties of electric currents. Among that, one is what is actually current. You know, current is the rate of flow of charges. Rate of flow of charges. That means charge flowing through a particular region in 1 second. And electric current, so we can write as a charge by time. Now, so electric current is equal to charge we used to represent with the Q and time with the T. So it is equal to Q by T. The unit of electric current is actually what is Q is in coulomb and T is in second. The actual unit of electric current is coulomb per second, and it is, we used to say as what is ampere. Coulomb per second is called ampere in the name of the scientist Andre Marie Ampere. In the name of the scientist Andre Marie Ampere. Some smaller units are, which are the milliampere and microampere. And ammeter, this device, ammeter is used to measure current. Which device is used? Ammeter is used to measure current. Here you can see the device ammeter, which is used for measuring current. Now, then we discussed about another term, potential, that is electric potential. Electric potential. What is actually electric potential? It is the work done. It is the work done to bring unity charge from infinity to a point, and that work is termed as electric potential at that point. What is actually electric potential? It is the work done to bring a unit positive charge from infinity to a point, and it is termed as electric potential. Then another term is potential difference. Slight difference is only potential and potential difference. Potential difference is the work done to move a unity charge from one point to, suppose a point A to another point B. That means electric potential difference is the work done. Work done to move unity charge from one point to another. That means here electric potential difference we used to measure in terms of volts, which is the unit electric potential difference volt. Here we know what is potential difference is the work done to bring unity charge from one point to another. So potential difference is equal to work by charge. Work by charge. We know the unit of potential difference is actually, the unit of work is joule and a unit of charge is coulomb. So the actual unit of potential difference is joule per coulomb. What is the actual unit of potential difference, it is the joule per coulomb, and this unit we name in the name of Alessandro Volta. So the unit of this we taken as joule per coulomb is taken as a volt, and its symbol is V. And voltmeter is used to measure potential difference. This is the instrument which is voltmeter. It is used to measure potential difference. Now we use a meter to measure current. Similarly, for measuring voltmeter, we use what is this device, what it is called voltmeter is used to measure potential difference. Now here you see potential difference is actually what is work by charge. Unit of potential difference 1 volt means if 1 joule work is done to bring 1 coulomb charge from one point to another, then work done by charge, that is potential difference, there we can say as 1 volt. And voltmeter to measure potential difference always be connected in parallel to the device where we want to measure potential difference. These are the things we discussed in our last class. So we are going to discuss a new term that we want to know. Is there any relation between potential difference across a conductor and current flowing through it? What we want to know? We want to find out is there any relation between current flowing through a conductor and the potential difference applied. For that, we can do on experiments. See, here you can see a battery eliminator. This is the ammeter. That means from the positive of the battery, we connected to the positive of the ammeter. From there, we connected, that means from the negative of the ammeter, we connected to the positive of the voltmeter. Then from the negative of the voltmeter, we connected to a key, and from the key again to the negative of the battery. And we want to measure potential difference across this nichrome wire. And this nichrome wire, see here, this nichrome wire we connected parallel, because we want to measure the potential difference here. That means in between the ends of this nichrome wire, we want to measure potential difference. So we connected this voltmeter parallel to it. Here see, this voltmeter is parallel to this wire. Now here this ammeter which is connected, see, from positive to this positive and negative, it is connected in series. Now by applying a potential, see here, you can see, now see, we are applying potential. Here we applied potential is 0. See, what is the current? See, you can see potential and current. Here you see potential is 0. In this voltmeter you can see that the potential is 0 and the current is also 0. That means when the potential is 0, current also 0. That means potential V and current I. That is, you can see potential is 0, current also 0. That means from this you can understand, to flow current through a circuit there must be a potential difference. To flow current through a circuit there must be a potential difference. Because of that, here the current is 0. Why? Here potential is 0. Now I am going to apply a potential here. See, potential of 2 volt is applied. Now you can see the readings in this ammeter and also altimeter. You can see the readings of the ammeter and altimeter. Now when we applied a potential of 2 volt, here you can see altimeter reading is 1.1. When you observe that, you can see, and the current through it is 0.2 ampere. Once again you observe this current, this in this is 0.2 ampere, and here potential difference you can observe as 1.1. Now again the applied potential is increasing. See, applied potential, now I given here battery potential 4 volt. Now what is the potential and current in this ammeter and altimeter? See, current and altimeter readings you can observe from this. Now when you apply this current, now the current becomes 0.6 and potential difference is on 2.6. You will get approximately 2.6. You can see here. Now see, current here you can see in the ammeter, that is how much? 0.6. Approximately you can see here how much is the current here. Not approx 6 here. It is only 5. Here is only 5 is coming, and here you can see potential difference, and that potential difference when you observe, that is approximately how much? 2.6. In between 2.5 and 2.6, that you can take as 2.6 or 2.5. And again the applying voltage is increasing. See, applied voltage increase to, that means at first I given no potential, then no current. See, when applied potential is 0, there is no current. When the applied potential, battery potential given, that means EMF, open circuit potential, that is I given how much 2 volt potential is connected, but potential difference across it is how much 1.1, and the current through the circuit is 0.2. Now again applied potential increased to 4. And now the current becomes 0.5 and potential difference is 2.6. Now the potential difference applied, how much? Here I applied potential difference. How much is given? Potential difference now applied potential is 6 volt, but you can see the potential across it is 4.5. And when you observe current through this ammeter, you can see current in this. And the current through it is 0.9. That is in between 0.8 and 0.9. You can see that. Now this is the current and potential. Now we can find out V by I. See, from this table, applied potential 0, current is 0. And when the potential is 1.1, current is 0.2. Now V by I, that means 1.1 divided by 0.2. That means we can remove, this will come as how much? 5.5. Here see, 2.6 divided by 0.5. We can remove this one. By dividing this, we will get what is 5.2. And again this 4.5 divided by 0.9. See, this will get 5. What you can observe from these values? See, when we find this V by I ratio, we get 5.5, 5.2, 5. That means here all the values nearly equal. Here all the values nearly equal. This shows what is V by I. that ratio is a constant. V by I ratio is a constant, and this is the key we used. After using this key, we want to remove, otherwise our battery lost its charge. Okay. Now, from this observation, what are the things we got? We got potential difference, current, and its ratio also. Now, we are going to find this ratio, what it means. For that, we can draw on graph with a V along the, V means potential difference along the x-axis, and I current along the, potential difference across the y-axis, and this one along the x-axis. Now, with these values, if we draw a graph, we get a straight line graph like this. We get a straight line graph, that means V by I graph. V by I graph is a straight line. V by I graph is a straight line. That means voltage and current. That means voltage along the y and current along the x-axis. We get a straight line graph. This was observed by George Simon Ohm, and so this is called Ohm's law. What is Ohm's law says? That means potential difference when we applied across a conductor, current flows through it. That current is directly proportional to the potential difference we applied. That means V proportional to, that means V proportional to I. That means current through a conductor is directly proportional to, current through a conductor is directly proportional to potential difference we applied. That is V proportional to I, or V by I is equal to a constant. V by I equal to a constant. And that constant is called resistance of the conductor. That means V by I, that means that we got here. That means 5.5, 5.25, that ratio. This V by I, that is a constant, that means that ratio is a constant. And what it is called? It is called resistance of the conductor. Resistance of the conductor. So, how we can state Ohm's law? That means potential difference across a current carrying circuit is directly proportional to current through it. Otherwise, current through a conductor is directly proportional to potential difference applied if the temperature remains constant. If the temperature remains constant. What is the condition required for this value to be a constant? That means temperature must be a constant. If the temperature changes, this value may change. That means when we keep this circuit in on condition, that means this one can be get heated up somewhat, so the resistance can slightly be changed. The resistance can be slightly be changed. And once again, statement of Ohm's law. Current through a circuit or a conductor is directly proportional to the potential difference applied when if the temperature is constant. How it we can represent mathematically? That means V proportional to I, or V by I is equal to a constant. But that constant is R, and R is the resistance. What it is? R is the resistance of the conductor. We can define this resistance. See, if the potential applied is 1 volt, then current through it is suppose 1 ampere. Then resistance R is equal to, we know V by I is equal to 1 by 1. That is, resistance is 1 ohm. Ohm is the unit of resistance. Which is the unit of resistance? Ohm. How we define 1 ohm? If the current through a conductor is 1 ampere. Current through a conductor is 1 ampere. When we apply 1 volt potential, then the resistance of that conductor is 1 ohm. 1 ohm is the resistance of a conductor. When 1 ampere current flows through it under a potential difference of 1 volt. So the unit of resistance is ohm. How we represent it? This letter is used to represent ohm. And how we can define 1 ohm? How we can define? If the current through a conductor is 1 ampere under the applied voltage of 1 volt, then the resistance of that conductor is 1 ohm. Okay. Now we got idea about what is the unit of resistance. Now we want to find out how the resistance of a conductor depends. For that we can do one activity. For that, though you see Ohm's law circuit diagram here it is given, and how that we can draw. This is the set, and this suppose our nichrome wire, this nichrome wire, and this is the ammeter to measure current, and this is the key, and suppose this ammeter we can connect for convenience, that means here we connect ammeter, that means from positive, see from this positive we connected to the positive of this one, that means this red cap is represented positive and black is negative, that means from the positive of this, that means from this red one we connected here red, that means from positive we connected positive of the ammeter, and from its negative we go to the what is that means from the negative, see from the negative this wire is coming to the positive of the voltmeter, so this voltmeter here we connected parallel to this one, see here, and this negative, this is a key. This is the circuit diagram used to measure Ohm's law, that means to verify Ohm's law. The circuit diagram we used here to verify Ohm's law is that means from the back positive of the battery we connected positive of the ammeter, see this red one is the positive, from there we connected to this positive and negative, from its negative to the positive of the voltmeter, then its negative to key and come to the negative of the battery, and here this key, plug key is given here. This is the circuit used to you want to remember how to draw circuit of Ohm's law. How to draw the circuit to verify Ohm's law. The circuit diagram you want to remember how to draw it. Battery from its positive of the ammeter, and from negative of the ammeter, positive of the voltmeter, and from negative to the negative of the battery. In between them there is a key. And see, voltmeter is connected parallel. We are measuring actually potential difference across this resistor. This is the nichrome wire. This is the nichrome wire which is shown in this circuit diagram, this one. Now, Ohm's law we know, and the ratio V by I we know it is a constant. Then also the unit of that constant, what it is called, that constant is the resistance, and its unit is ohm. We also know how to define on ohm. We also know how to define on ohm. See, now we want to find out the factor affecting resistance. Resistance of a conductor. The factor that affects resistance of a conductor. For that, we require a torch bulb, then a nichrome wire, then 10-watt bulb. To do this activity, that means to find the resistance of a conductor, we record these following items: a torch bulb, nichrome wire, 10-watt bulb. Then we make the circuit as shown. This is the point X and Y. Here we can connect a positive, negative in this battery. Here ammeter. See, here we can on switch also. Now here this positive, negative. Now negative. Here this way come positive. At first, we introduce this nichrome wire in between this gap X and Y, and observe or measure current here. How much current is flowing through the tip, that we measure. Otherwise, we want just observe it. What we did, the nichrome wire we connected here. Okay. Then after observation, we remove this nichrome wire from there. Now we introduce this torch bulb here. That is this bulb here. And again we observe current through this ammeter. Now after this torch bulb we remove, we introduce this 10-watt bulb. Now here the bulb with the power of 10 watt. At first we included nichrome wire in the circuit. Then this torch bulb. Then 10-watt bulb. In each case, we measure current in this ammeter. From this ammeter, we measure current. Now, from this observation or measurement, we can understand current in each case is that is noticing. That means in each case, current differ. Why? This current here differ. That means it is due to the resistance of the material. That means here when we observe current, in each case we can observe that current is noticing. Why that current is differ? Here current differ because the resistance offered by this material. That means some of the material allows current easily passes through it, and such materials we used to say as conductors or conductor. Some material allows current passes through it easily, and such material we used to say as conductors. But like this nichrome wire, that offer some, that means we know what is in the metal, there are free electrons. There are free electrons. But the flow of the free electrons opposed by some atoms in it. So there develop resistance. And material like nichrome that offer somewhat greater opposition. So such a type of material we used to say as resistors. Resistors. That means when current flows through the metal, the atoms in it oppose the flow of it up to a certain extent, and such type of material we used to say as resistors. And some other materials that offer some more resistance, and such type of material are called poor conductors. What is called poor conductors. And some materials which can offer higher resistance than these poor conductors, and that we used to take as insulators. What is called insulators. Now, what are the things beyond the resistance of a conductor? When we discussed about resistance of a conductor, we want to know about what is conductor, what is resistor, poor conductor, insulator. Once again, conductor means which allows electric current passes through it, very easily. Okay, it passes, electric current passes through it very easily without much resistance. But resistors are the material that can offer certain amount of hindrance to the flow of electrons through it. Some kind of hindrance through the flow of electrons in it, and such material are called what is resistors. And some other material that can offer more hindrance than resistors are called poor conductors. That are called poor conductors, and material which offer very high hindrance, and that is called insulators. Now the four terms you want to remember: conductor, resistor, poor conductor, insulator. Conductor, resistor, poor conductor, and insulator. Okay, can you remember this four terms? Which are they? Some of the material that allows electric current passes easily is called what is conductor, and some other are resistors that can exert or extend its hindrance to some extent, and poor conductors and insulators. Poor conductors and insulators. Okay, now see, we discussed about Ohm's law, and also about that graph. How is the graph? We obtained when we draw the values obtained from Ohm's law. That graph is a straight line, but one condition is given there: temperature must be constant, or temperature must remain same. Some of the material that obey this Ohm's law, and such material are called ohmic resistors. But most of the material offer this, but some of them does not obey this. That means when we draw the graph is a straight line. That resistor is called ohmic resistor. If the graph is not getting like this, sometimes the graph is like this. That is not a ohmic resistor. That is not a ohmic resistor, because here V by I is not a constant. Here V by I is a constant. So here it is. Here this resistor is ohmic resistor. This is not a ohmic resistor. Which is the equation we got from this one? We got the equation. That means V by I is equal to R. Here V, what is actually potential difference in volt. You want to remember when solving problem, V is for potential difference and its unit is in volt. Then I, what is I? Its unit is given ampere, SI unit is ampere, and it is represented to current, to represent the current. And for this R, what is ohm? It is for resistance. This for resistance. Okay, this is for resistance. Now we can solve some numerical problems given. See in our text. With these equations, we can solve two questions given in our text. Among that, first one from page number 208. Page number 208. How much current will an electric bulb draw from 220 volt source if the resistance of the bulb is 1200 ohm? B. How much current will an electric heater coil drawn for a 220 volt source if the resistance of the heater is 100 ohm? See here given, you know, V is for volt to represent potential difference. I current and unit is ampere, and R resistance unit is ohm. Can you remember this all? Okay, you should remember about these units and also each letter. Now we can solve this problem. How much current will an electric bulb drawn from a 220 volt source? See, 220 volt source means its potential difference V is given. Potential difference is given. If the resistance of the bulb is 1200 ohm, resistance, which letter R? 1200 ohm. See, potential difference is given. How much? 220 volt. Resistance also given. We want to find out current. How much current it can draw? Drawn means it can use. See, we know current I is equal to what is V by R. Because V by I is equal to R, or R is equal to what is or I is equal to what will get I is equal to V by R from this relation. See, V here how much 220 and R 1200. Now we can cancel 110. Now 22 divided by 120. How much will come? 22 divided by, we can divide with 2, then we'll what will get 11 by 60. In 22, 11 times 2, in 120, 60 times. Can you divide this one? In 11, we cannot take 60. So, by putting on decimal, 0 is given. How much? 1. 60. Remaining is how much? 0. 5. 500. In 500, how many times? In 500, how many times 60 will come? 8 times. How much? 500 by 8 times 480. That means 20. Then again 0 we put 3 times. Then current is how much? 0.183 ampere. This is the current that bulb is using. How much current is using? 0.183 ampere is using there. How much? 0.183. Now the question B. See, what is in question B? How much current will an electric heater coil drawn from 220 volt source? That means the 220 volt source means the potential difference is 220 volt. If the resistance of the heater coil is 100, resistance is given. Now we want to find out how much current that is I is equal to V by R. That is 220 divided by 100. 10 we can cancel. Then 22 divided by 10 is equal to how much? 2.2 ampere. This is the current that is using. The current used is how much? I is equal to V by R. That is equal to 220 by 100. That is equal to how much? 110 we can cancel. Then 22 by 10 to divide with 10. One decimal we can put from right to left. So we get how much? 2.2 ampere current is drawn by that heater. Okay. The another problem that we can do in the next class. Now we can recall what are the points we discussed today. Mainly we discussed about Ohm's law. Very important one is Ohm's law. What is the statement of it? Under a constant temperature, current through a conductor is directly proportional to the potential difference. How mathematically we represent it? V proportional to I, and from that V by I is equal to a constant. The name of this constant is resistance, and its unit is ohm. Also 1 ohm is equal to 1 volt by 1 ampere. 1 volt by 1 ampere is 1 ohm. That means under a potential difference of 1 volt, if 1 ampere current flows through a conductor, then its resistance is 1 ohm. Then also we discussed about ohmic resistance and the resistors which obeys Ohm's law, and that are called ohmic resistors, and some other does not obey this V by I, that is equal to R in the way as a constant, and that we cannot consider as ohmic resistors. Then very important one is the graph of Ohm's law. Here V along the y-axis, that means potential difference along the y-axis, and current along the x-axis, and the graph is a straight line. From this graph, if we take the slope of this, also we can get a slope when we finding the value of y. This y value and this x value, if we take, that means V by I will get, that is also equal to R. Then we discussed about different type of resistors, conductor, poor conductor, and insulator, and we solved one numerical problem related to Ohm's law. Some other problems there that we can do in the coming class. Okay, with this we can close today's class.